So this is module 2, and in this module we'll be covering about UART, RS-232, RS-485, Modbus and Ethernet. We'll cover Modbus and Ethernet in the coming modules also, but the basics of Modbus and Ethernet and how it is applicable to serial communication will be covered in this module. So first is UART. UART stands for Universal Asynchronous Receiver Transmitter, and this is not just a protocol. It is a protocol, but it is not just a protocol. It is a universal logic that is used uh, among various communication standards, asynchronous communication standards. So it is not limited to a particular protocol. It can be used by lots of different interfaces. So what UART does is it defines TX and RX lines. TX is transmit and RX is receive. So it defines that a particular device that follows the UART shall have separate UX and RX lines. It does not specify how many lines per TX, how many lines per RX. It only mentions that it should be separate. UART mentions that TX and RX should be separate. And like I told in the last module, it is running asynchronous clocks at both ends. So there is a clock in a device A and there is a clock in a device B. And both of these clocks are running asynchronously, meaning start bit is used to synchronize the clock momentarily and send a few bits of data until the clock starts to get out of sync. Then you stop the synchronization, stop bit, and then start bit. So that is sequence of a UART. The data length between a start bit and a stop bit can be 7, 8, or 16. So that you can be, not industry practice is 8, but you can also go with 7 and 16. And parity is actually, parity is like a error detecting mechanism. It is not an error correcting mechanism. You cannot say where the error has happened, but you can say that you can identify that an error has happened. And parity is also not reliable. There is a probability that an error has happened, but you cannot detect it. So that is always there. So basically, parity is three types. There are no parity. You cannot use a parity at all. That is called no parity. And then you can use even parity, where the number of one will be even, and we can use an odd parity where the number of ones will be always odd. So by parity, let me clearly define what a parity is. Moving on to the whiteboard. So on odd parity, suppose you're having seven bits of data and 1 bit of parity, and your data is, say, this is 7 bits. So suppose your data is 0 1 1 1 0 0 1. So here the data is having 4 ones and 3 zeros. So suppose you are selecting an even parity, the parity bit will be selected that such that the total number of bits is even. So here already there is an even number of bits. So you don't need a 1 here, you need a 0. So parity will be 0 in case of an even parity. And for an odd parity, what happens is the odd parity will be such that the number of ones, it will try to keep odd number. So now we are having an even number of ones in the data. So to make it an odd number, the parity will be 1. So if it is an even parity, the parity will be 0 in this case. And if it is an odd parity, the parity will be 1 in this case. So the parity is decided by the hardware in advance, and it will be sent along with the data. So suppose you're sending a 7-bit data, the 8th bit will be the parity bit. And the 8th bit will be parity bit, and it will be set such that the parity condition is satisfied. So suppose in the slide, say for example, you're selecting an even parity, the parity bit will be set such that the total number of ones, including the data and parity bit, will be an even number. So suppose you're using an even parity and you count the number of ones, and suppose it is an even number, there is a very less chance that an error has happened. And suppose you're detecting an odd number of, you're counting the number of ones, you're detecting an odd number, then your receiver is understanding that okay, I am using even parity, but I have counted odd number of ones. So that means one, at least one error has happened. So that is what parity is. Parity, like using parity bit can help. It cannot help to resolve the error. It can help to identify the error. So once you identify the error, you can request for retransmission, depending upon the higher level of protocol that you're using. You can request a retransmission, and a retransmission shall be set. But parity, the thing is that even if an error has happened, there is always a chance that it is not detected. So you, if you want to like get more depth into the this concept of parity and error correction, you can always do so. So that is what parity is. And fundamentally, UART does not define any voltage level. So most people have a misunderstanding that by UART you are using a 0 volt. So by voltage level, what I mean is, what is a 0 volt? What is representing a bit zero, and what is representing a bit one? So there is different voltage levels defined. For example, say a TTL. A TTL is transistor level, or sorry, transistor logic. TTL stands for TTL, transistor logic. And by that what I mean is, a logical one is represented by 5 volts. So this is 5 volts, say this is 5 volts, and this is represented by 0 volts. So that is what a TTL is. So most probably UART uses this logic. It uses 5 volt to send a 1, it uses 0 volt to send a 0. But that need not be the case, because UART does not define the voltage level. You can use any other voltage level, and you can use any other connector, you can use any other medium. UART does not define any of this, but the most common is TTL. So that is what a UART is. Moving on to an RS-232. Now RS-232 is not a protocol. It does not define the logical constructs for sending and receiving data. It only defines the physical aspects. Means UART uses UART. Sorry, RS-232 works over UART. Means the data is sent fundamentally the same as UART, and in addition, you are defining the voltage level. So UART is defining how you send the bit, what is a start bit, what is a stop bit, the data, length of the data, all that is defined by the UART. And then the voltage level is defined by the RS-232, and number of channels, or how the cabling is done, is defined by this RS-232. The pin out, see, you can see the pin out of an RS-232 connector. This is a DB9 connector. It is having 9 pins. The RS-232 defines the use of each pins, and it defines the pin out. It defines the type of connector. The type of connector is DB9, and it defines the handshaking or flow control. Handshaking and flow control I'll explain in the next slide. And RS-232 also supports full duplex. Full duplex means it allows for the transmitter to send data and receive data at the same time. Because it is having separate transmit and receive lines, the transmitter can send data and simultaneously receive data in a different pin. That is what full duplex means. And it is point to point. By point to point means device A, one device A maybe, can use RS to send data to another device, point B. So there will be two devices, and the data will be sent from one point to other. There will not be a third device C where that C can also listen to the data. It will not be the case. By point to point means one device can send the data to other device. That's all. It is not like a network of devices where one device can send data to any other device. It is not the case. By RS-232, we can only implement point to point communication. And coming to this handshaking, what I mean by handshaking is is the fact that suppose the transmitter is sending the data, but the receiver is not ready to receive the data because the receiver is busy doing something else. Maybe it is busy recording a transducer value. Maybe the buffer input of the receiver is full. For XYZ reasons, the receiver is busy doing something else and it is not ready to receive the data. But even though the transmitter has sent the data, so what happens is, even though transmitter has sent the data, receiver is not ready, the data is lost. and the transmitter does not understand that the receiver has not received the data unless there is some mechanism in the higher level protocol. The receiver cannot know that the sender cannot know that the receiver has not received the data. So that is what handshaking or flow control pins are used for. So these pins are dedicated inside this DB9 connector. These pins are dedicated so that there is a handshaking between the sender and receiver. So when the RTS or request to send is there, when this pin is high and there is a 5 volt in this pin, for example. So sorry, in the RS232 does not use 5 volts, it's a plus 13 volt. So suppose there is a logical high in this pin, it means the device is requesting the transmitter to send the data. It is indicating that I am ready to receive, and this is clear to send. So similarly, data send set ready. So all these pins are used to communicate between transmitter and receiver, so that whatever is being sent or whatever is being received is meaningful. And there is a ground pin and there is a ring indicator, which I will not be discussing. It's a legacy pin. Basically, modern implementation of RS232 will only be using these two pins. Handshaking is not necessary because it is part of a legacy system. Nowadays, RS232 will be used over some other higher level protocol or higher level application which takes care of all the handshaking. So there is no need of hardware handshaking. The higher level protocol which is used above RS232 will take care of the handshaking. So these pins are not required at all right now if you are using in a higher level protocol. And if you're not understanding when I'm saying at a higher level protocol, what is a lower level protocol or what is a lower layer link or a higher layer link. If you're not understanding these terms, that don't worry, I'll explain the protocol stack or the OSI model later, and then you can come back to this module and you'll understand what I was talking about. So basically, what handshaking is a way so that the receiver and transmitter knows when the other party is ready to send or receive, or if the and the parities I discussed in the previous UART slide is that parity is a way so that error can be detected if it happens. And this fact I would like you to remember is that RS232 in itself cannot send or receive data. It needs to use the UART interface. So the UART is an interface and the RS232 is the standard. So the standard uses the interface to send the data. So you cannot use a standard without an interface. So the interface is UART, and you can call the UART a protocol, but the actual UART the UART predates the conventions of protocol. So when UART was first used, there was no specific protocols or standards that were being used. UART was designed originally by Bell Laboratories, and at that time, people were not talking about protocols and standards. That is why you cannot specify it as a protocol. It is a interface actually, because UART is not defined by software or communication engineer. UART was defined by chip manufacturers for ways to communicate from one chip to other. It was not an original communication protocol. It was just a interface for a chip to communicate with one another. So that is why because UART, the name and standard predates the conventions of a protocol and standard, we cannot specifically say UART is a protocol. We can call UART as an interface because UART is what is designed by chip manufacturers. And RS232 is a standard, is an electrical communication standard which uses the UART interface to communicate data. So one such scenario is there. This is a host PC or a PC, and this is another PC. It is using an RS232 link to communicate the data. And RS232 levels are such that you cannot send more than 10 to 15 meters. And you can send data for more distances, but with slower speed. So here the term baud is there. So I like to explain what baud is at this point. Going on to the slide. So what is baud? Baud is basically bits per second. So the most common baud rates that are being used are 9600 baud. You might have already heard of 9600. So basically it translates to bits per second. It translates to the number of bits being sent in a particular second. So that is how you translate. That is how you understand baud. Baud is bits per second, and by 9600 baud you mean 9.6 kbps. And this is how you wire a RS-232. There will be a connector at this end, and there will be a connector at this end, and you will be using at least three lines, because you don't need, like I told in the previous slide, you don't need the handshaking information at all, because that is legacy system. You can just turn off flow control, and again you can use RS-232 as it is, as just three wires. This will be twisted pair, and a ground reference wire will be the shield of the cable. So this will be, suppose you are using a cable, it will be a twisted pair cable between RS TX pair, and the ground, you can use the shield of the cable can act as a ground. You don't need to have a separate ground pin, that is. So that is how easy RS-232 is. You can just use a twisted pair, and you can just communicate with two devices. The only thing is, disadvantage is that it will be always point to point. You cannot have multiple devices communicating with each other. It will always be from point device A to device B. So that is why people have come up with a new serial communication interface standard, that is RS-422, or its modern variant RS-485. So nowadays people are not even using RS-422, because its modern slightly different variant is RS-485. Both are comparable, is even better standard. So now again this works over UART. So RS-485 is again a communication standard which works over the UART interface. By interface, what I mean is that the chip, the communicating chip underneath is using a UART chip. It is using a UART IC underneath the interface. And additionally, this also defines voltage levels. Like previously, the voltage level defined by RS-232 was plus and minus 13 volt. RS-485 also defines voltage levels, but the voltage levels is not fixed per se. It is depends upon the manufacturer, but always it will be above plus 5 volt and below minus 5 volt. The logical is using, again it is using balanced signals. So in this slide I did not explain what is unbalanced signal and balanced signal. So now I would like to explain. An unbalanced signal is always referred to the ground. For example, so this is a TX line and this is the ground line. So the ground will always be at 0 volt, and the TX voltage that you will be measuring is with reference to the ground. So this 0, what you are measuring here, this is ground potential, and the Tx will always be with reference to the ground. So this is 5 0 like this. It will be referred to the ground. This is called unbalanced signal. This is unbalanced. Means the reference is the ground. That is basically that. What is meant by unbalanced signals. Now again, this is balanced signal. A balanced signal will be Tx plus and Ts minus. So there is no ground reference here. There is no ground reference in a balanced signal, but in an unbalanced signal there is a ground reference. That is basically the difference. And when you look at the waveform will be like this. So for Tx plus I am using a red color, and Tx minus I am using a blue color. So you'll have a little more clarity. The waveform will be like this. For a Tx plus it will be like this. So this is some bit pattern, and the same bit pattern in the opposite polarity will be there with Tx minus. So this is how you send data in a balanced signal. This is what is called a balanced signal. So balanced signal is also called differential signal. Means the you are looking at the difference of two signals. Means let's say tx plus is a and tx minus is b. So the different signal, the difference signal is actually a minus b, and it will always be either a positive value or negative value. And if positive value is represented by 1 and a negative value is represented by 0. So with the advantage that you're getting, first thing, you are not using a ground reference. Second thing is you're using two wire, that is twisted pair. You're using a twisted pair for sending data. And the third thing that your advantage that you're getting, because of the fact that you're not using a ground reference and you're having two wire, any noise in the channel, the twisted pair will be like this. And any electrical noise, suppose an electromagnetic noise has come into the channel, so it will affect both the conductors at the same simultaneously, right? It will not, it will be like both conductor will experience the same noise. It will not be like tx plus is having some noise x and tx minus will be having some noise y. It will not be like that. Both conductors are in twisted pair configuration, they are in close proximity, and they will experience the same average noise. So the same average noise will be experienced by both. And because you're having the difference b equal to a minus b, the noise will cancel out. So suppose a is having a is equal to a prime plus noise and b equal to b prime plus noise. When you are having taking the differential signal, it will be a prime plus noise minus b prime minus plus noise, and the noise will cancel each other, right? That is the beauty of balanced communication. So whatever noise is happening will get cancelled out. Because you are using a twisted pair, any noise in the channel will affect both the channels, and that will get ultimately cancelled out because you are using the difference between these two voltage levels for deciding your bit, whether it is a 0 or 1. You're not absolutely taking the reference with ground, you are using a differential reference. Because your differential reference between two channels, that is why it is called a differential signal, it is called a balanced signal, and there is no, the noise gets cancelled out. And if the noise is getting cancelled out, you can use longer distance, higher baud rate. You can use all these things with the balanced signal. That is the advantage of a balanced signal, is that you can use it over larger distances with higher speeds without caring for noise. So going back to the slide, that is what is a balanced signal, also called a differential signal. So here in the pinout, it's the same, it uses the same DB9 connector. The RS485 uses a DB9 connector, and it is having separate plus and minus fins for transmit. Unlike the previous slide where you see one transmit pin, one receive pin for RS232, because unbalanced signal. One for sending, one for receiving. But here you see two for sending, one twisted pair. This is a twisted pair for receiving the data, and this is for sending the data. And it's a differential output, differential and balanced signals. See, and these four wires, there are four wires, right? Four wires for sending and receiving data signal. Data wires are four numbers, and handshaking, like I told you, same. These are backwards capability pins for legacy support, and then ultimately there is a ground pin. But the beauty is you don't need a ground at all. And one more thing is that it can be used point to point, means from one device to another device, or it can be used in a multi-drop network. What I mean by a multi-drop network is, it is a network where there is a master device, one master device, and many slave devices. or more than one slave device. That is a multi-drop network, where suppose if I'm sending a data, everyone will receive the data, but the data is intended for one person and they can decide who that person is. Suppose it is like it is like uh, going to a classroom and calling someone's name. So everyone hears the name, but only the person who actually has the name will respond. So that is what a multi-drop network is. A multi-drop in an vertical net, all the devices will be connected to the same communication bus, and when one of the device tries to communicate, only the device with that particular address will respond, even though everyone is getting the data. Suppose this is A, this is B, and this is C, and this is D. Suppose A is requesting a data from B. Both these devices are able to listen to A, but they will choose not to respond. So such configuration is called a multi-drop. This RS-485 can be used in a multi-drop fashion, depending on the higher level. Again, higher level, and I'll explain in the last module. So this is, and again, this can be used as a two-wire. Two-wire is fully duplex. You can means you can send and receive at the same time. That is what full duplex is. And you can use simplex, means you can send and receive, but not at the same time. You can either send or receive, and you cannot do both simultaneously. That is a two-wire. So in the two-wire method, the master device is having separate ports RX and TX, but they are internally shorted, or you are shorted in a separate externally shorted. But either you send the data, and the receiver will, after receiving your data, they'll use the same channel, same two wires to return the data. So this is a multi. This is what is a multi-drop network is. This is a master, and there is three slave devices, but you can connect more slave devices with two wires for data and one wire for ground. And these two wires are internally separate ports are there. TX and RX ports are physically separate, but they are internally shorted in the two-wire configuration, or you can externally short it in the two-wire configuration, so that either this bus can only be used by one device. Either master is sending and the server cannot use the bus, or either one of the server is returning the data to the master, and the other servers cannot respond. So that is what a two-wire method is. And in a four-wire method, the TX and RX is separate, so you can send and receive simultaneously. Means you are using four of these wires to communicate and one ground wire. So this is a four-wire configuration, and this is a two-wire configuration of the same RS-485 standard. And you can use a four-wire and two-wire method for any of the RS-485 devices. It is completely backwards compatible. And RS-485 is most probably commonly used in SEM data. It is used in transducers. It is used in energy meters. It is used in water meters. It is used in solar inverters. Whereas an RS-232 is used from point to point, means from relay to computer, from laptop to computer, from point to point devices, means it cannot be used in a network, but it can be used from one device to another device. Whereas in a RS-485 can be used in a multi-drop network, where more than one devices are connected in parallel, like SEM meters are connected in parallel, and there is a one PC which is used to retrieve data from the SEM meter. So that is a RS-485 multi-drop network. Uh, and for example, when you are using, say you are having some water meters in your substation, and you're using you have having four water meters, and you're forming a multi-drop, and you're having a PC at your control room to fetch data from these water meters. That is an example of an RS-485, but you cannot do that with RS-232. So clear distinction between RS-232 and RS-485. Fundamentally, the voltage levels are different. The configuration of the wiring is different. That is, RS-232 is using an unbalanced signal, whereas RS-485 using a balanced signal, and the pin out is different. Two pins for transmit, two pins for receive. Four-wire configuration is different. Two-wire configuration is different. Multi-drop arrangement is different. Voltage levels are different. So Even though in nowadays we are using in substation, the connector is same. That is the thing. The DB9 male connector or female connector that you are using for RS485 and RS232, both are same. So most of the people that I see in substation gets confused because the connector is the same. They assume that the underlying standard or the underlying interface is the same, but the interface is not the same, or the pinout might not be the same. Uh, so you should not get confused, even though the connector is the same. Why my connection is not working, or why my converter is not working? You might have seen RS485 to USB converters, or RS232 to USB converters in the substation, and they cannot be interchanged unless specifically written in the manual. They cannot be used interchangeably. For an USB to RS485 converter cannot be used with the USB to RS232 converter, because fundamentally the pin is different, the voltage levels are different, the signaling is different. This is using a differential signal, whereas RS232 is using a balanced signal, unbalanced signal. So that is what you should be keeping in mind when using these devices to communicate with relays, or with SM meters, or with any other Modbus devices, or when you're using these devices in RTU network, when you're using this device in a SCADA network. Basically, you're using multiple devices at the same time, so you'll be most probably using RS485 rather than an RS232. That is what you have to keep in mind. So this is the configuration. This is a summary of the thing. The RS232 is a point-to-point, 485 is a multi-drop. So this slide covers what I have discussed for the last few minutes. And the maximum distance, again, the maximum distance, don't be biscuited. The maximum distance is decided by the baud rate that you're using. So for very low baud rate, say for example 9.2 kbps or 9600 baud, you can use RS232 even beyond 15 feet. Or you can, suppose you're using a lower speed, you can even go further than the designated maximum limit. And the voltage level is also defined here. So here see, RS485 is having a differential limit. It is not absolute voltage that is marked. It is a differential voltage that is marked, B greater than A and A greater than B. That is to be noted. So now I hope that you have got a fundamental difference. You understood the fundamental difference between these three interfaces, communication interfaces, and I hope that this knowledge gets transferred in your day-to-day activities in the substation. So you have a better understanding of when you see such a DB9 connector. So you can already think about what an RS485 is, or RS232, or what it might be using. So that is the takeaway from this module. In the next module, we'll be covering Modbus RTU in detail. Thank you.